In this question, we have a sphere of mass m and speed u. M and speed u. It impinges directly on a stationary sphere, 0, and mass 3m. The coefficient of restitution is e. Find in terms of e the speed of each sphere after the collision. We'll call these p and q. Got my little table. v1 minus v2, p minus q, over u1 minus u2, which is just u minus 0, is equal to minus e. So p minus q is equal to minus eu. Conservation of momentum, m1 u1, so just mu plus 3m times 0 is equal to mp plus 3mq. Dividing by m, we're going to get u is equal to p plus 3q. And we're trying to find out what p and q are here. So p is equal to u minus 3q. So over here I can say u minus 3q minus q equals minus eu. So I've got 4q. If I bring it to the right, I make it positive, and that's going to be equal to u plus eu. So q is equal to, if I factor out the u times 1 plus e and divide by 4, I'll get u over 4 times 1 plus e. And then for p, I'm going to have here p is equal to u minus 3 times q, which is 3 times u over 4 times 1 plus e. So I'm going to have p being u minus 3u over 4 minus 3eu over 4. So I can combine the first two here. I have a full 1 minus 3/4, so I've got a quarter u, so I just got u over 4 minus 3eu over 4. And I can factor out u over 4 to end up with 1 minus 3e. So this is p, speed afterwards, and q, speed afterwards. Now we're looking at kinetic energy. We're asked to show the loss of kinetic energy here is 3mu squared over 8 times 1 minus e squared. Okay, let's look at kinetic energy before. So it's going to be half mu squared twice, but because this speed in here is 0, we're just going to have a half mu squared. Actually, we have it laid out there. That's what the kinetic energy is before. Afterwards, it's a half m times p squared plus a half 3m times q squared. So this might take a little bit of simplification here. We have p and q over to the right. So let's work these out here. A half m times p squared. So if we square p, we're going to get the first one of the product. So we're going to get that squared. So u squared over 16 times, I multiply this out, and then I'm going to get 1 times 1 and 1 times minus 3e twice, and I'm going to get plus 9e squared. And I could tidy that up just to be mu squared over 32 times 1 minus 6e plus 9e squared. If I do one beside it here, I've just simplified this one first, obviously, so now I'm going to do this one. So I have a half times 3m, well, I can just change that to 3m over 2. Might be just a bit tidier. 3m over 2 times q squared, so it's going to be this guy squared times this guy squared. So I'm going to get u squared over 16 times 1 plus 2e plus e squared, which is going to give me 3mu squared over 32. 3mu squared over 32 times 1 plus 2e plus e squared. Tidying this up, I have mu squared over 32, and I have 3mu squared over 32, so that gives me 4 of them. So I have 4mu squared over 32, and I'd have to add this guy and this guy to see what we're multiplying them by. So that's going to be by 1 and 1 is 2, minus 6e and plus 2e is minus 4e, and I've got 9e squared plus e squared, which is 10e squared. I'm seeing something here I've done maybe it's an easier way to do, or you might tidy it up a bit better. If I just take mu squared over 32 on the outside, let's see what happens on the inside. I'm multiplying it by this 1 here, but if I imagine this 3 going on the inside, it's going to be mu squared over 32 times 3, so that's going to have to be plus 3, and maybe I'll just do that now. I'll do mu squared over 32 times 3 plus 6e plus 3e squared. I should have multiplied that out, of course, to cancel the 6e's. So I'm going to get 1 plus 3. The 6e's will cancel, this one and this one, and then I'll have plus 12e squared. So I'm going to get mu squared over 32 times 4 plus 12e squared. And I can factor out a 4 there, can't I? I can get 4mu squared over 32 times 1 plus 3e squared, which is just going to be mu squared over 8 times 1 plus 3e squared. So that's the kinetic energy after. Before, we had a half mu squared, so it's going to be a half mu squared, or mu squared over 2 minus mu squared over 8 times 1 plus 3e squared. That's going to be the loss. Let's have a look here. Factor out mu squared over 2, maybe. Mu squared over 2, I'd have to multiply that by 1 over 4 to get mu squared over 8 by 1 plus 3e squared. So that's going to be mu squared over 2 times 1 over 4 plus 3e squared over 4. So if I have mu squared over 2 minus that guy, so now these two together are mu squared over 2 times 1 minus 1 over 4 minus 3e squared over 4. I think this is the right thing. Mu squared over 2 times 3 over 4 minus 3e squared over 4. Is this correct? I think I can factor out of these two. I can factor out 3 over 4. That's all I can do. So it's 3 over 4 times mu squared over 2 times 1 over, no, just times 1. If I factor out the 3 over 4, 1 minus e squared, which is going to give me 3mu squared over 8 times 1 minus e squared. And if you're not sick of these types of questions already, you will be now. That is the correct answer. So let's go back up to this question. Let's see where it takes us next. If e is equal to a quarter, find the percentage loss in kinetic energy to the nearest percent. Well, that's just filling in. If e is equal to a quarter, I don't really need to do that, do I? And find the max possible percentage lost in kinetic energy. Okay, well, I'll do both of these parts. Okay, so that's after. Before was mu squared over 2. Was it mu squared over 2? A half mu squared, yeah, mu squared over 2. So m over 2 times u squared. Let me just see, we're letting e be a quarter. Okay, so we're going to sub that into the after, and we get it in terms of mu squared, and then we can compare the two. So after is mu squared over 8 times 1 plus 3e squared. Did I write a half there? I think e is equal to a quarter. Just let me check. Yeah, e is equal to a quarter. We're going to 1 plus 3e squared, so 1 times 3 times 1 over 4 to be squared, which is 1 over 16. So we're going to get mu squared over 8 times 1 plus 3 over 16, which is 19 over 16. So this looks like 19 is prime, so we can't simplify it. 19 mu squared over 80 and 48 are 128. So this was it before, mu squared over 2, so a half mu squared. In terms of that, in relation to the denominator 128, that would be 64 over 128 mu squared. So it started at 64 mu squared. It became 19 mu squared if you just eliminate the denominator. So 64 started 64 and went down to 19, a loss of 45. So the loss was 45 over what it started with times 100 will give me the percentage loss. So it's going to give 70.3125%. Do they ask for the nearest percent here? To the nearest percent, better round it off to 70 just to be 100% accurate. And then the last question in this section of 7b, find the max possible percentage loss in kinetic energy. The max possible percentage loss in kinetic energy where E can be between 0 and 1. So let's have a look at the loss here. Well, there's no E in the first one, so it's only really afterwards. So how can we maximize this? Right, well, if E is equal to 1, let's just give it two values. We give it 0 and 1 just to be 100% accurate. Mu squared over 8 times 1 plus 3 times 0, so that would just be mu squared over 8. So an 8 mu squared is the worst that it can become, or the least, and the max then will be mu squared over 8 times 1 plus 3 times 1 squared, so 1 plus 3, which is 4. So that will be equal to mu squared over 2, which obviously is what it began at. So we can go from mu squared over 2 to mu squared over 8. We can go from mu squared over 2 to mu squared over 8. So that's from a half to an 8. So from 4/8 to 1/8. So we are losing 3/4, which is 75% would be the max loss.